hope in every sphere of life is a privilege that attaches to action. Think about that. No action, no hope. If you want to have hope for a better life, free of illness, for yourself, for your family, for your friends, then action will be necessary. And the action, in many cases, is medical research. The NIH was built on that vision. A vision shared by researchers, medical doctors, and very much by this Congress, and has used its annual budget over the course of many decades to support the very best in biomedical research, including the work of now 132 Nobel Prize winners who have been supported by NIH in the work for which they were recognized. And you can see the evidence of that, and some of that is in the brochure you also have in your packet about NIH in terms of the consequences of this work. For instance, we have seen over the last 40 years a 63% decrease in deaths from heart disease, 63%. My predecessor, Elias Zerhouni, did a little back-of-the-envelope calculation and determined that that came about on the basis of $3.70 per American per year, about the cost of one latte, to be able to reduce heart disease deaths by 63%. Deaths from stroke, 70% reduced in the last 40 years. Of course, there are other contributors to that outcome. NIH conducting research that provided much information about risk factors, about interventions, and that led to the development of new drugs like statins. But none of those reductions would have been possible without that bedrock foundation of research conducted by the NIH. We have vaccines now that protect against influenza and meningitis and even cervical cancer. We have survival rates from cancer that are improving. We have, in fact, HIV survivors now. If you are diagnosed today at age 21 as being HIV positive, your life expectancy is age 70. And that is a breathtaking thing to be able to say when you consider where we were just 15 or 20 years ago, where that was basically a death sentence. But we're not done. We have a long way to go with many of these conditions, even though we've increased longevity now by about 1 year every 6 years since 1990. And even though we've reduced disabilities by almost a third in the last 25 years for people over 65, we still have a lot of work to do. I might point out, though, that the evidence that this investment is valuable comes, from my perspective as a physician, primarily from what it has done for human health. But in this current climate where we are all deeply concerned about the costs of anything the federal government is spending money on, we have to think about economics as well. Economists have estimated, though, that the overall gains in U.S. life expectancy from 1970 to 2000 were worth an estimated $95 trillion. If you saw Michael Milken's op-ed in the Wall Street Journal last week, he points out that even a 1% reduction in cancer deaths would save our nation $500 billion. And we have started to see those reductions in cancer deaths. And of course, NIH also supports jobs directly. Our some 325,000 jobs supported by the NIH grant system all over this country in every state of the nation are high-skill, high-paying jobs and are contributing in a major way to American competitiveness. And I must say, as a bit of a downer, we can't be too confident about that competitiveness in terms of our stature in the rest of the world. To be honest, we have seen some slippage in that regard, as support for medical research has been essentially flat for about the last 8 years. A survey done by a foundation called the Information Technology Innovation Foundation in 2009 basically looked at the top 40 industrialized nations and assessed their productivity and what they call innovative competitiveness using a series of some 16 metrics. Of those 40 countries, the U.S. ranks 6th in 2009. That doesn't sound too bad, although it might not be what you'd hope for, because we would have been number 1 20 years earlier. But here's the scary part. They also looked at the rate of change over that decade in terms of American innovative competitiveness. Of those 40 top industrialized nations, we ranked dead last. And if you're concerned about our future as an economy and as a driver of scientific innovation, one has to look at that number and wonder how can we turn that around. Well, NIH is in a position, I think, to offer a lot in that regard. There are challenges. America is, after all, getting older. Chronic diseases will consume a lot of our healthcare dollars. Alzheimer's disease is just one example, threatens to reverse hard-fought longevity gains, and economic disaster looms if we cannot figure out how to turn that around. Vexing problems of health disparities still need attention. But all of those are part of our agenda. And I know we can meet those challenges together, even as we are this week looking at significant difficulties in identifying where the funds will come from. For investigators that receive grants from NIH, and again, most of our money, 83% of it, goes out there to universities across the land. Their ability to get a grant from us has dropped in the last few years from about a 1 chance in 3, which has historically been about what it was, to now less than 1 chance in 5. And that gets to be extremely difficult, particularly for a new investigator who's just trying to get their program started. And we want to do everything we can to encourage and nurture those young scientists to follow the ideas that they have come up with to make those next breakthroughs. But I know we can meet those challenges, and I know that working together with organizations like UMR and with these leaders in the Congress who have been identified in this Profiles of Promise. I do remember a time, perhaps a little more than 20 years ago, where there was a debate about whether there should be a human genome project. And interestingly, people were worried. The economy was kind of not doing so great at the time, and there was concern about whether we could afford to start something new and innovative at that point. And I will say it was members of the Congress who were particularly effective in their leadership in getting that underway, and I will refer particularly to Senators Domenici and Harkin, who led that effort to find a way to get this started, because it was going to be such a breakthrough in terms of our understanding of how life works and how disease happens, and that has certainly been coming through. As the person who then had the privilege of leading the Human Genome Project and now leads the NIH, I can tell you the number of things that we can do now because of that visionary step. This is quite breathtaking. Take cancer, for instance. Cancer is a disease of DNA. Cancer comes about because of mistakes in the genome of that cancer cell that causes it to grow when it should not have been growing. And we now have the tools to be able to assess that at the most detailed level you can imagine. And that gives us the opportunity to actually target therapy in a very rational way for individuals with cancer that we could not do before. We see a deluge of molecular discoveries about cancer and diabetes and heart disease and Alzheimer's and Parkinson's, hypertension, all of these conditions where we've been able to describe them, but we haven't really understood at the detailed molecular level what has gone awry. And now those discoveries have happened, many of them in just the last 3 years. And we want to be sure that those don't sit there unattended to. But many of them are of uncertain clinical value. We're not quite sure how you take that discovery and move that forward into a treatment. NIH has been pretty good at doing that over the years. A paper in the New England Journal last week documented, if you look at the last 20 years of drugs approved by the FDA, and you look particularly at the most novel ones that were considered to be the most high need, 20% of those drugs came from NIH.